So we're going to do addition and subtraction of rational numbers. We put that down. Adding and subtracting rationals. Numbers. Rational numbers. Okay, so let's take a look at a basic one. Let's see if we can find an easy one. Okay, the main thing you want to do, okay, let's start right here on page 301, and let's look at example 6. Okay, when the denominators are the same, it's rather simple to do. All we got to do is just add the numerators and keep the common denominator. So this is just going to be simply, this is a 4, it's going to be 3 plus x plus 4, or 7 plus x over x. The main thing you want to do when you get through with this, you don't want to do is cancel off these x's. Okay? You can only simplify a 7 plus x with a 7 plus x. So you're basically done. You know, if the denominators are the same, it's simple. But if the denominators aren't the same, that's where the fun begins. So let's take a look and see what we can do. And of course, when you get through, you want to try to reduce if possible. But if it's not possible, you don't have to worry about it. So I'm going to jump over here to number 9. Here we have 2a over 5 plus 3b over 2a. This is on 302, number 9, example 9. Okay, so what I usually do on a problem like this, there's a couple of different ways you can do it. Okay, I'll show you a couple of different ways. One way is to make sure we have common denominators. So 5 times 2 is 10a, right? So we have to make it 10a. I mean, there's no other way we can simplify it. So we can multiply the first one by 2a, and the second one by 5. So this is 10a, and whatever that becomes, and this is 10a. I'm just kind of concentrating on the denominator. Now I have my common denominator. I'm going to put 10a down, and now I'm going to see what my numerator is. 4a squared times those together, and then 15b plus 15b. And there's no way I can really add those together. There's nothing I can factor out to kind of reduce it down. So if you can't factor it, you can't cancel it. You have to be able to factor, then cancel. So this problem cannot be reduced. Okay, that's one way to do the problem. Let me show you a little shortcut. This is called a crisscross applesauce. We're going to multiply these two numbers together diagonally down. That'll be 4a squared. We're going to multiply diagonally the other way. 5 times 3b will be 15b squared, or just 15b, I should say. And then we're going to multiply the bottom numbers. 5 times 2a is 10a. Criss-cross applesauce. Criss-cross applesauce. Kind of a faster way of doing it, then you don't have to write all this down. It's just a little shortcut. Works with a binomial type problem, but if you have a lot of terms, it won't work. But it's kind of a short way of doing it. As long as these are fairly simple equations, we can use this with just regular numbers. Say I had 2/3 plus 1/4. Okay, Criss plus cross applesauce, 11/12. So a fast way to add two fractions together, rather than having to say, okay, I'm going to put a 4 here, 4 here, 3 here, 3 here. You know, it's just kind of a shortcut way of doing it. Crisscross applesauce, or crisscross smiley. Make a little face here. Okay, so anyhow, that's kind of the idea behind it. Um, can be useful. We can use this also like something you have a over 3 plus uh, 1/2, let's say. So 2a plus 3 over 6. See, very simple to add those together. Now, most of the time we don't have something that easy, so then we get stuck with a little tougher problem. So let's try one that's a little bit harder. This example 10, 3x squared plus 3xy over x squared minus y squared plus 2 minus 3x over x minus y. So this one, obviously not so easy to crisscross applesauce. You could, but the problem is you're going to end up with a huge denominator. So on this type of problem, it doesn't lend itself very easily. This problem a lot easier, but this one much tougher. Usually on these problems, we don't want to factor out the numerator because, even though it's factorable, we might want to wait and see what happens. So what I'm going to do is, first of all, just concentrate on the denominators. Work on your denominator first. Concentrate on that denominator. So let's factor this out, x squared minus y squared. So we have, fortunately on these problems, there's a lot of writing. So we're going to factor this down. We'll try to make it not as much as possible, but, and we're going to factor this one down. Okay, it's unfactorable. Okay, so now I have this thing factored, and this side right here is kind of like a little kid. He's whining like, look at Johnny. Johnny's got an x plus y. I don't have it. So we're going to put these in parentheses, including the numerator, and we're going to multiply this side by an x plus y so that it balances out. So they both have the same thing, x plus y. But what we do to the denominator, we must do to the numerator. All right. So they both get x plus y. All right. Now all of a sudden we can just kind of expand this out. But unfortunately here we're going to have to do a FOIL, huh? We're going to have to kind of FOIL that out. Let's put our common, so we're successful in getting a common denominator, right? They're both the same. It doesn't matter if they're in the same order, just so you have an x minus y, x plus y. So let's see what happens. Nothing happens here. But let's multiply this out. And the only way we can do that is with a FOIL. I don't see any shortcuts here, so plus 2x outside, first term times first term, outside 2y, inside minus 3x squared, and last term minus 3xy. So watch your signs, that's all. Well, looking at this, it actually works out pretty nice. I see this 3x squared and a negative 3x squared. I see a positive 3xy and a negative 3xy. So it looks like I can cancel those two out. I can't add these together, but I could factor out, I can see it. It's going to be, well, I'll write the step down. It's going to be 2x plus 2y over x minus y, x plus y. But I see I could factor out a 2 out of here. So I'm going to reduce this, take out the 2. I could have done it maybe right away, but I wanted to show you. So now I factor out the 2, and I say, oh, I've got a matchup. So in order to reduce, I'm basically done at this point. But I want to reduce this if possible. Just like any other fraction, cancel off those x plus y's. They go into each other one time. And the final answer, is 2 over x minus 1. So it's kind of cool little problem. Quite a bit of work. Let's go back over and recap it just a little bit. First thing I did was kind of try to get the denominators to be the same. And whatever I do to the bottom, I have to do to the top. Then I went ahead and distributed this out by doing a FOIL. After I FOILed it, I could combine like terms, get it down to this point. And then I said, wow, okay, I could be done here, but let's see if I can reduce it, a better answer by factoring and canceling F and C. Factor and cancel. All right. Try another one. Here's a messy one with subtraction. All right. So let's try this one. If you like doing these problems, then you like math. If you don't like doing these, well, then you don't want to major in math. That's for sure. Okay, so I have this problem. It's subtraction. So when I see a subtraction problem, I want to make sure I put my numerators in parentheses. I might even do it to this one to make sure, because this, I'm going to eventually have to distribute this minus sign. So I want to be a little careful. So now I'm going to concentrate on the denominators. I'm going to try to factor those down. Okay, I'm thinking 2 times 3 isn't going to work because 2 plus 3 adds up to 5, and I need a 7. So this is going to be y, and 6 and 1. And they both have to be negative to add up to negative 7, but they have to multiply to give you a positive 6. Okay, same thing on the bottom here. You're going to factor that out, y and y. Now, one of these is going to help you. You know, there's a good chance this isn't going to be 3 and 2, because you want something, maybe it's probably going to have a 6 or a 1. So let's take a look at this. It's probably going to be 6 times 1. And I want a negative 5, so negative 6 plus 1. See, because they have to multiply to give you a negative 6. If they were 3 and 2, they would add up. You could be a negative 3, negative 2, but then that would give you a positive 6 here. So you have to kind of play with it. Now, they're almost the same, except that they're not quite. All right. So they do have something in common, the y minus 6, but this one right here wants a y plus 1. He looks at his neighbor. He says, hey, look, Johnny's got a y plus 1. I don't. So he wants a y plus 1, and the top wants a y plus 1. This one over here saying, oh, mommy, look, he's got a y minus 1. I don't have one. So he wants a y minus 1. Now they're happy. Maybe I'm just bringing up my own childhood. I don't know. Anyhow, they both have the same denominators. Let's see. Y minus 1, y minus 1, y minus 6, y minus 6, y plus 1, y plus 1. Kind of a horrible denominator, but a long one. Let's write it all down. Y minus 1, y minus 6, y plus 1. That's our first thing. Make sure that this is all the same. Now let's concentrate on the numerator, which unfortunately we're going to have to do a FOIL on these. First times first, outside, inside, last term times last term, and maybe you could do a little shorter one, minus, and we want to make sure this is in a parentheses, it's minus that whole thing. So let's do a FOIL here. This will be y squared minus y plus 3y minus 3. So a lot of being careful about signs, you know. Now we're going to combine all the like terms and see what we got. Pretty messy problem, huh? And we're running out of room too. Let me see if I got enough room to do this. Let's try it and see. Let's see, what are we going to do? Combine the like terms, yes. Sometimes you could do it maybe above this, but I'm going to go ahead and write it down. 2y squared, I put these together, 3y plus 1 minus, I'm going to distribute this. This would be y squared. This would be a positive 2y if I put them together, and if I distribute this minus sign, it'd be a minus 2y, and then a plus 3. So I'm distributing this minus sign, a negative 1, to each one of these terms. I combined these together first, and then I distributed it. Whatever. Okay. You know, sometimes instead of writing down the common denominator, sometimes we just write CD for common denominator instead of having to write that down each time. And let's see where we finally end up with. I'm going to have to do it on another sheet of paper because I'm running out of room. There might be more to this problem. Put it up here. All right, so I've got, so I have 2y squared minus y squared is y squared. 3y negative 2y plus 1. 1 and 3 make 4. Over the common denominator. Now, I'm looking at this to see if I could factor this down. I don't think I could, so I think I'm pretty much done. So I'm just going to leave this. So I don't think there's anything else I could do to this. Sometimes this will factor, and then you kind of reduce it. Let me just write this over here on this problem. Then I have it all on one sheet of paper. Over y minus 1, y minus 6, y plus 1. There you go. You know, Christmas is coming around the corner. These would make nice Christmas presents to people. You know, you could like put a little design on them and then send them off as Christmas cards. No. Okay. Well, it was an idea.
We could give people our math notes.
Yes, there you go. Next future generation, you know, the next algebra people. All right, well, that was it. Pretty much that's all there is to these problems. Just a lot of hard work. Okay, on the next page is maybe some tricks and things like that. Let's take a look at some of these. But that's basically the idea behind them. And especially on subtraction. Subtraction, make sure, this is really essential that you put the parentheses. And when you get through with this, when you do your FOIL, make sure that you put that in the parentheses and then distribute. And there's just a lot of terms, you know, and sometimes you get lucky and it's correct. Okay, a over 2a plus a cubed over negative 2a. Well, you can kind of see on this one, they're almost the same. We don't want to really we could put a negative here, multiply this by negative 1 and make this negative 1. I guess you could do that. Or sometimes what we do is we just bring the negative sign up to the numerator. Either way, you could handle this because basically the denominators are the same. So let's just bring this negative up. So it looks like I have a minus a cubed. And I might not write all these steps, you know, I probably could have just jumped from this step to this step, and then I can factor out an a. That gives you a 1, huh? Minus a squared over the 2a. And that way, because this is there's no addition. So we can reduce this. And here we remove the a, so now we can cancel those a's because it's just a factor. So we can cancel those out, And I don't know, they factored this out, but I don't think it's really necessary because nothing's going to cancel. You could factor it 1 minus a, 1 plus a, or you could just leave it 1 minus a squared over 2. So when you have the negative sign like that, just it's easiest just to bring it up. I thought about maybe making this the negative a, but and then switching them around, but then you could have had a squared minus 1. But it's this is just as good. All right, here's another one like that. This is a subtraction problem. What I do on this one is I'm going to change this to move this kind of, I'm going to think in my head, I'm moving this up. So if I change this on the bottom, I'm going to change this on the top. Sometimes when I do a problem like this, I'm going to change this to plus, and then I'm going to change this sign to plus. You have to do 2 changes. I could have done the same thing here. I could have changed this to plus and then changed this sign to a minus. You see? Change, 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 change. So I changed this from a negative and I changed this subtraction to addition. Okay, then I would have x squared plus x cubed over 5y. And I probably just stopped there. When, they went ahead and factored it down. I don't really see the purpose of that because nothing's going to cancel. We try to factor them when we can kind of see there might be a possibility of canceling, but otherwise you're just doing extra work. So, this is like a little negative trick. Change this sign. Same thing here. I could have just changed this sign and changed the operation. All right, let's see if we can do it on this one then. 5x over x minus 2y. And these are little tricks you can use that make it a little bit faster to do the problem. So these are almost identical, aren't they? If I switch this around, show you what I do. When I switch this around right here, make this x minus 2y, I'm going to change this sign from minus to plus. Switch, 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 switch. Then I didn't have to worry about, I could still have had this in a parentheses if I wanted to, but now it's a plus sign. Switch this around. Keep the minus sign between the 2 terms, and then switch this symbol right here. Switch the operation. So now let's see what I have. I have 5x plus 3y minus 7, nothing fancy there, over the x minus 2y. And that makes it a lot faster, you see. All right, want to try the monster problem? Let's try this one. Last one. This is on page 305. I don't know why they have so many steps on this. It doesn't look like we really need that many. Okay, first of all, when I'm looking at this problem, I see that this could be easily factored, right? And I can see that I don't want the 2 to come first. I want these always, usually, not always, but most of the time, I want the x to come first. So I want this x minus 2. I want this to be x plus 2. So let's go ahead and factor this out. X minus 2, x plus 2. Okay. Let's switch this around. X minus 2. And if I switch the minus, I'm going to change this sign right up here to negative. Double switch. Minus, now I'm not going to switch this around. I'm going to switch it around, but I don't have to change the sign because it's addition. Okay, only when it's subtraction. Switch it, switch the sign. You can just 2 plus x, x plus 2, same thing. Okay, so I say I almost have, I have some minuses here, so I have to be kind of careful. I see that this is x minus 2, x plus 2. So this one needs an x plus 2, right? Just kind of jot it down here and put it over here. And then I see this one needs an x minus 2. And I need to get a better pen, huh? X minus 2. All right, so now I've got my denominator. My denominator has been worked out. I've got an x minus 2 on all the terms. Ding, ding, ding. I got an x plus 2 on all the terms. So I've got my denominator. Now I'm just going to go ahead and calculate my numerator. 2x minus 5 times 5x minus, I'm taking the negative with the 5, minus 10. Same thing here, minus 1x plus 2. Negative times negative. So I'm distributing this negative 1 to all the terms. Now I'm going to combine like terms. Let's see, I've got 2x minus 5x minus 1x. What would that be? Negative 4x. Is that right? No, let's see. Yeah. And then whole numbers, negative 2, negative 10 plus 2, negative 8. This was a negative 4x. X minus 2, x plus 2. Sorry about that. So I combined the like terms here. Bing, bada bing, bada bing. Okay, now I'm going to factor out a negative 4. And this would be an x, but this sign's going to change, plus 2, right? Negative 4x, double check it by distributing it. It looks okay. And I have x minus 2x plus 2. So I see these two terms are going to cancel. And I've got my answer. Nice little answer to this. So it looked in the book like you had to have a million steps, but really not. I usually write it like this. They kind of put the negatives in the middle. I don't think we need that. You don't need necessarily a parentheses. Sometimes I'll leave the parentheses, but you know, if you do, that's okay. But that's your answer to this thing. So, you know, they had a lot more steps in the book because they're trying to show you each and every step. But sometimes you can do, you know, the work on the problem. Sometimes it's good to use a pencil and a pen, kind of like to save yourself a little bit of writing. So you can see this wasn't originally in the problem, but I put it in. Sometimes I circle it. They kind of, if I have to go back and restudy this problem, how I solved it, then it makes it easier to say, okay, that wasn't originally there. I changed it. And I can see what I did to the problem to get that common denominator. That's the key. Work on your denominator first. And then after you get that, simplify the numerator. Combine like terms in the numerator, distribute or whatever. And then finally simplify, factor and cancel. So those are kind of the steps, but not worrying so much about the numerator, more about the denominator than about the numerator. Okay? Do you have any questions? Let me stop this recording.